Okay, so we're going to take a look at two problems here. We're going to compare Marcy hiking and Benjamin hiking. Marcy's hiking is shown in a table right here, but Benjamin's hiking is shown in a graph. So we need to find our slope from this graph. And some of us have said we're having some trouble finding where I should put the point when I'm looking at the graph. Remember, I'm looking for a rise over a run. So on this graph, in order to be able to find a rise and a run, I have to decide which one is the rise and which one is the run. My y value should be my rise because it tells me how far up or down I'm going, and my run value should always be my x. If I'm looking at Benjamin's hiking line, so I need to look for a place on the graph where I can see exactly where it crosses for x and y, like right there and right there. Also remember that 0, 0 is always a point on our proportional graphs, because if he doesn't hike for any amount of time, he won't go any miles. Once I've identified a couple points, all I have to do is count my boxes for my rise over my run. Since we're looking at the point right here with the red X, we're going to find out how much does it rise to get to the dot that we made. So we're going to count 2, 4, 6, 8. So my rise, which is on top, would be 8, and my run is how far over I had to go to get to that point. 2, 4, 6, 8, 10. So my rise is 8 and my run is 10. I could choose to divide the 8 over 10 and make it 0.8, 0.8, which is 8/10 or 8/10, just like it is in a fraction. I could also choose to reduce it and divide it down by 2 until I had 4/5. Now, I would write that into my equation of the graph as y equals 4/5 x. My unit rate is also 8/10, which means every hour he goes 8/10 of a mile. Now that we have Benjamin's, let's take a look at Marcy's hike. We can see that she's also going in distance per hours. And her first set of data on the table says she went 5 hours and 6 miles. So I can use division to find my rate of change, or I can see that the top is moving by 5s and the bottom is moving by 6s. Now that I've looked at Marcy's hike and I see that the distance changing is 6 every time and the time changing is 5 every time, it's important to stop and take a look back at Benjamin's. If I look at Benjamin's, my distance was my y value and my hours was my x value. So my distance on Marcy's hike should also be my y value, and my time should also be my x value. Since my y value is my rise over run, I need to be able to write it as a rise over run. So let me write that as 6/5. Now, it's hard to be able to compare the two fractions, so if we turn them both into a decimal, it's easier to compare their unit rates. Remember, Ben's unit rate was 8/10. Marcy's unit rate equals 1.2. All I did to get that unit rate was divide her distance by her time. 6 divided by 5 equals 1.2. So Marcy is moving at a rate of 1.2 miles every 1 hour, and Benjamin is moving at a rate of 8/10 every 1 hour. So it's easy to see when we compare them this way that Benjamin is hiking much slower than Marcy. She's moving faster because she's covering more ground in the same amount of time. And that is how we compare two different proportional relationships that are shown in different ways.